Hi, welcome to day 10. We're going to solve polynomial and rational inequalities. So we're going to solve those polynomials and rational functions that we've been working on for the last few days. And we're going to solve them for inequalities by using a number line approach. A number line approach is just really a one-dimensional look at a two-dimensional graph. So for these examples, they're not too hard. First one I made pretty easy for you. I want to find the zeros, the positive, and the negative values for this function. So another word for zeros is obviously my x-intercepts. So when I look at this problem, I see my x-intercepts are equal to positive 7, negative 1/3, and then positive 4. Remember, we want to make it equal to 0. So these are my x-intercepts. So off of that, I'm going to make a number line. And what I'm going to do, I'm just going to draw a number line. I do not put 0 on my number line because none of these numbers are 0. I do put them in order. I don't care about the spacing. So my lowest one is negative 1/3, and then I have 4, and then I have 7. I'm going to put little zeros above them, these tick marks, because those numbers for x represent the zeros of the graph. So these numbers here are all x values. Okay, now we have to figure out what is the y value, what is the function value, either positive or negative, whatever. So we need to go back and do our leading term. Our leading term is going to be, let's say I have an x times a 3x, and this last one is a negative x. So my leading term is equal to negative 3x to the third. And if we recall, this negative 3 means my right side will go down to negative infinity. So what I should put over here, on the right side of the number line, because I have the number line broken up into 4 segments, 4 regions, I should do it. It's broken up into negative infinity to negative 1/3, negative 1/3 to 4, 4 to 7, and 7 to infinity. Those are the 1, 2, 3, 4 region it's broken up into. So this right side is going to be a negative value because after 7, all the values are negative going down to negative infinity. But because this is an x cubed, that means the left side is going to do the opposite. So the left side is going to go up to infinity. But I'll get back to that in a second. These x-intercepts, these zeros, are the spots where this number line will change from positive values to negative values, or what I say, it's going to alternate from positive to negative and vice versa, unless we have a bounce. And we'll talk about that in the next problem. So this right side is negative. This next region, I turn positive. This next region is negative. And the last region is positive. And I do see that my left side and my right side are opposite values based on it being x cubed. Okay, so those things in red represent, put them here, these plus and minus signs in red represent y values, or what the f of x is doing. So I'm not drawing a two-dimensional graph to see where things are above or below the x-axis. This number line is kind of like the x-axis, and I'm showing what's happening. So between negative infinity and negative 1/3, I would be above the x-axis, so I have positive y values, and between negative 1/3 and 4, I would have negative y values. So part B asks for where things are positive. Where are things? I don't want blue. I changed it. I swear I did. I want when things are positive. Or I want to know where the plus signs are at. So according to this graph, the plus signs are in the intervals negative infinity to negative 1/3 in union with 4 to 7. That's where I see the plus signs. And part C, is where I want where things are negative. And that's where I see the minus signs. And the minus signs are from -1/3 to 4, and union with 7 to infinity. So this function is positive on these two intervals, and it's negative on these two intervals. And the -1/3 and the 4 and 7 is where it's equal to 0. So we go with the next problem. The first thing I do is I want to find the zeros of the x-intercepts. And the first one is -5/2. The next one is +3. The last one is -1. But one of them is special. The squared represents a special one. Too close to the top. The squared represents a special. So this 3 is a bounce. And then I can go ahead and figure out what is the leading term. My leading term is going to be 2x times, the next one is x squared, and the last one is x. So my leading term is equal to 2x to the 4th. So I'm going to make my number line. I'm going to put these features on the number line, these x values, just in the order from left to right. -5/2, -1, 3. I'm going to put little zeros above them. I'm going to make notes. This guy is a bounce. Something special is going to happen here. Now with my leading term, I know with this 2 value, the right side is going to go up to positive infinity, and because of this 4 here, the left side is going to be the same, also going to positive infinity. But that doesn't really matter. I'm going to see it in the end. So because of this right side leading term of 2, the right side has to be positive. It's going to go up, up, up. I'm going to alternate unless there's a bounce. So this right side is positive, 0, but it bounces back to positive. That's what a bounce does. It means on both sides of the number 3, I should have the same value because it's a bounce. Then this goes negative, and then this goes positive. So you can see that now both ends are the same, and at x equals 3, we have a bounce of both sides being positive. Part B, I want to find the positive values, where the plus signs are at, and that would be, I have 1, 2, 3, 4 regions here. So -infinity to -5/2, union -1 to 3, union 3 to infinity. I have to break that up because even though they seem connected, they're not. Right at x equals 3, the value of the function is not positive, it is 0. And then this last part, I want when this function is negative, so I want the minus signs, and I only have one spot where there's a minus sign, and that is from -5/2 to -1. Now I'm going to do the same thing here, but I'm actually going to solve this inequality. I'm going to use my number line approach, but I'm not going to tell me where it's positive, where it's negative. I'm going to do that on a number line, but at the end I'm going to solve it. So my x-intercepts are equal to -1/2, +2, and +4/3. And I'm going to make my number line, and the smallest number here is -1/2, with a 0, then 4/3, and then 2. I should pay attention to my leading term. My leading term is equal to 2x times -x times 3x. My leading term is equal to -6x to the 3rd. What does that mean? Well, because it's -6, it means the right side goes down to -infinity. So I'm going to put a negative sign right here. Okay? And it's going to alternate, and there's no bouncers here. So it's going to be positive, negative, positive. And since this is x to the third, I should know my left side should do the opposite of the right side, so it's going to be up, and it does go up. But what am I really looking for? It says less than 0. That means I want the negative values. I want to know where it's negative, not including 0, just negative. So I'm going to circle the minus signs because that's where the function has a negative y value. And I'm going to mark those intervals down as negative 1/2 to 4/3, union 2 to infinity. And that is my result. Now I'm going to show you what it will look like if I did a two-dimensional graph of this function. Okay, so I'm going to show you what the graph of this function here at the top would look like. This 2x plus 1 blah 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 graph. Well, this light blue is like the x-axis. So I want the positive means be above it and the negative means be below it. So I would be above it, positive, x-intercept 0, negative below it, back to 0 x-intercept, positive above it, back to 0 x-intercept, and then negative below it, and going down forever. And this is what the graph would look like. And we've done those graphs. So this number line approach is just a one-dimensional look of this two-dimensional graph. I think it's a lot easier to solve these problems. I don't have to graph it. It takes more work. Okay, step 1, my x-intercepts. I'm going to note those. They're negative 1. They're positive 3. They're negative 4. But again, this positive 3 is special. It's a bounce. And when I want to do my leading term, the first one is x, the second one is x squared, and the last one is x, and I got my leading term is equal to x to the fourth, or better yet, 1x to the fourth. So now I can make my number line. In order would be negative 4 is the smallest, negative 1 is the next smallest, 3 is the next, and I should note that that 3 is special. It is a bounce. And because of this positive 1, the right side is going up to positive infinity, so that means this is going to be a positive. And then I'm going to alternate unless I have a bounce, and here at 3 I do have a bounce. So I have to be positive 0, bounce back to positive, negative positive, and I pay attention to this fourth root. The left should also be doing the same as the right, going up to positive, and it does match. Now when I solve this, it says I want the positive or the numbers equal to 0. So I'm going to circle the plus sign. That would be plus sign, plus sign, plus sign. And because it's including 0, I'm going to use brackets. So really, technically, this goes negative infinity to infinity. So my results are going to be negative infinity. Infinity has always got parentheses, comma, negative 4, bracket, union, negative 1, 3 bracket, union, 3 to infinity. That seems kind of silly to put it this way because they both include 3, so these are connected. So a better way of writing this would be, well, the correct way of writing this, not the better way, the correct way would be this. That whole, both these guys are positive and 0, so that whole one region is together. These are together. So the whole front page was about polynomial functions. The back side is going to be about rational functions. I'm going to use the same method, the same number line approach. Well, again, part A, my zeros are my x-intercepts. And my x-intercepts for this is going to be from the numerator. So my x-intercepts are positive 7 and negative 1. Part B, my undefined part of the graph is when I have a VA, and that's my denominator. And my denominator is has x equal to positive 3 and negative 2. So now I can make a number line of all this. So I have to put these features on. So the smallest number here is negative 2. The next one is -1. The next one is 3. The last one is 7. And 7 and -1 are zeros or x-intercepts. And -2 and 3, I'm going to make the little dashed lines. These are VAs. Now I should also pay attention to my leading term, except now I'm going to do leading term over leading term. And the leading term on top would be x squared, and on the bottom would be x squared, so my leading term is really equal to 1. Well, that's a positive 1. So my right side would go up to infinity, so I put a plus sign here. And every time I come to a feature, I'm going to alternate signs because none of these are bouncers. So positive, 0, negative, asymptote. We talked about this. If one side of the asymptote is negative, the other side should be positive. 0, negative, asymptote switches to positive. Okay. Also, even though we write that down, this is really 1x to the 0, and the left side, 0 is an even number, would also go up to infinity, and they do match. Part C is I want the positive values. And that's where all the plus signs are located. So I have 1, 2, 3, 4. I have 5 regions, and the plus signs are, well, there's a negative infinity here, there's an infinity here. Would be negative infinity to -2, union -1 to 3, union 7 to infinity. That is where everything is positive. And then part D, here's where everything is negative. That's where the minus signs are located, those regions. -2 to -1, union 3 to 7. And that's where I have the negative values. I can circle all this, and circle that. This next problem, I'm going to do the exact same thing, except my problem is that I got to factor it. I haven't factored it today because I had to do it sooner or later. So I'm going to factor this. I'm going to get x plus 1 over x plus 2, x minus 4. And x plus 1 times x plus 1 is really x plus 1 squared. Okay, well then I got to find part A, my zeros are my x-intercepts. And that would be -1, but it's special. It's a squared, it's a bouncer. Part B is where it's undefined, those are my VAs. And that is x equals -2 and 4. So now I can make my number line. Here's my number line. I have to put -1 on this number line. I have to put -2 on this number line and 4 on this number line. So these two guys are asymptotes. So these are VAs. And this -1 was a bounce, and that's key. So now when I do leading term over leading term, I do get x squared over x squared, which is equal to +1. So again, this right side will go up to infinity, so this guy here, the right side, will be a positive, and I'm going to alternate signs from the right to the left, positive and negatives, unless there's a bounce. So I go positive, negative, bounce, back to negative, asymptote, back to positive, and again, 1 is x to the 0, both ends are the same. Part C is when it's positive, so I want to know where the plus signs are at, and the plus signs are located from negative infinity to -2, union 4 to infinity. And then finally, where is it negative? That's the minus signs, -2 to -1, union -1 to 4. I know they seem connected, they're not. There's 0 in the middle. That's not where things are negative. Next problem, I'm going to do the same thing. I'm going to have to do a little factoring. There's nothing to factor in the numerator, but the denominator is x plus 4, x minus 4, and I want to know where it's greater than 0. We'll do that solving later. Let's figure out our x-intercepts. Well, there's only one. It's negative 3 on top. My VAs are from the bottom. That's x equals negative 4 and 4. I can make, I'm going to make it lower. I can make a number line of all this. Negative 4, negative 3, 4. Like I said, I do not care about spacing. There's only one x-intercept. But these guys are asymptotes. I should note them with red dashed lines. And these are VAs. And let me do leading term over leading term. I get x over x squared, which is 1 over x. What I really care about is that it's a positive 1. So because it is a positive 1, the right side is going to go up to infinity, so this guy is going to go positive. And I'm going to alternate. There's no bouncers here. So I'm going to alternate. I'm going to go negative, positive, negative. Now, both ends are opposite because if we really look carefully at this, this is really equal to 1x to the negative 1. That is an odd number. The left side should be the opposite. But now over here it says greater than 0. I want the positives. I want where the plus signs are located. I want the regions that have the plus sign. So I have a couple regions here, and that would be, the plus signs would be negative 4 to negative 3 in union with 4 to infinity. And that would be my solution. I'm going to go and show you what a two-dimensional look of this graph would be. So all I did below was copy the number line from above. And the idea is that because it's 1 over x, it has asymptotes, horizontal asymptote at y equals 0. But here's the idea. I have an asymptote here, so I have to be below the x-axis here. So it would be level off at 0 and go down to negative infinity. Over here, I would be above the x-axis positive, x-intercept 0, and be negative below the x-axis next to the asymptote. And this one would be all above the x-axis. And this would be a two-dimensional look of the graph of that original function. But I like the number line because it just accomplishes the same task, so I can solve my problem with less work. So I have to factor this, x plus 2, x minus 2, over x plus 4, x minus 3. I want less than or equal to 0 on all this. So my x-intercepts are equal to negative 2 and positive 2. My VAs are x equals negative 4 and positive 3. I'll do my leading term right now. My leading term on top and leading term on bottom is x squared over x squared. Oh, we're getting this 1 again. That's fine. My number line, I'll put it way down here. I have negative 4, negative 2, 2, and 3, and negative 2 and 2 are zeros. I'm going to put those as zeros. And negative 4 and 3 are VAs. I'm making little dashed lines. And this term here is positive, so my right side goes up to infinity. So this is a plus sign on the right. No bouncers anywhere. Alternate positive, negative, positive, negative, positive. And we already talked about 1 is really x to the 0. Both ends do the same. But I have to look at what kind of solution do I want. It says I want the negatives or things equal to 0. So I want all the negative signs, including the zeros. So I'm going to have to include negative 2. I'm going to have to include positive 2. But the negative 4 and 3 are asymptotes. They're not included. So it's going to be parentheses negative 4, comma, negative 2, bracket, including that 0, union, bracket, 2, comma, 3, parentheses, because that's a vertical asymptote. I'm only including negative 2 and 2 with brackets because they are zeros. They are including the 0. Okay, thank you.